So we can get the distance traveled in nth second as Sn minus 1. So now we can replace Sn with un plus half an square, where n is in second, and we can replace Sn minus 1 with un minus 1 plus half a into n minus 1 whole square. So finally we get Sn is equal to u plus 1 by 2 a into 2n minus 1. Now a word of caution: whatever equation that we have just discussed, they are valid only for constant acceleration, and all those equations are vector equations, though we can also use them for motion in one dimension, that is when a particle travels along a straight line, and we can decide either to or flow direction to be positive, and accordingly we can decide the sign of various quantity. For example, if a particle is traveling along a straight line from A to B with some velocity u, so we can decide that the direction from A to B, that is this direction, is positive, and the direction from B to A is negative. So accordingly we can say that the particle has positive velocity. Suppose there is another particle which is traveling from point B to point A with velocity v. So the velocity of this particle will be negative. Similarly, if the acceleration is in the direction from A to B, it will be positive, and if the acceleration is in direction B to A, it will be negative. So even though the equation that we have discussed are vector equations, we can use them for the motion in one dimension after we have taken care of sign. Now let's have a look at another displacement time graph. So here we can see that the slope of st curve is decreasing, that is displacement time curve, it is decreasing. So this is the case of deceleration. Also there is a point on the curve where the slope of the graph is 0. This is that point, and then the slope of the graph is equal to the velocity of the particle. So oh man, it sucks. Now let's talk about displacement time graph. In displacement time graph, the displacement of particle is plotted against time. Generally we take displacement along y-axis and time is taken along x-axis. So first let's see a typical displacement time graph. So here, as we can see, the displacement is being taken along y-axis and the time is being taken along x-axis. Suppose this point is S1 and this point is S2, so S1, S2 is the actual graph, and which is a straight line, and this straight line makes an angle theta with the horizontal. So the slope of the straight line is nothing but tan theta. Since this slope is constant for the whole graph, that if we want to take the slope of the graph at any instant, it is same as tan theta. So here we have a constant slope graph, so which indicates that the velocity is also constant, since velocity is given by dx by dt, and dx by dt is nothing but the slope of the displacement time graph. So if the slope is constant, it means that velocity is constant. So whenever the displacement time graph is a straight line, it would imply that its slope is constant, which would imply that its velocity